Hey guys, welcome back to another Default Cube cgmatter tutorial, and today we are doing part 3 of the procedural node series. I know it took a while for me to actually sit down and record this, but that's because I was waiting for a new microphone. And now, everything should be working. Yes, I had some recording issues earlier, so I want to make sure everything's going before I invest a lot of time. And like usual, we're going to be using version 2.81, and I'm going to keep pointing that out until we switch to a different version. And yeah, let's make that full screen. So what are we going to be talking about today? Well, a while ago I said I'd be talking about value, color, maybe a bit of math, and that was supposed to be part 2. But of course, we had to talk about the material system, so today we are doing all those things. So in the first episode, we learned that the way to get to the shading workspace, or just to get the shader editor in general, is either to, I'm going to stop repeating this after a couple episodes, but again, you can either open a window, go to the shader editor, do your thing, or just hit shading workspace. And this time for real, I need you to have, it wasn't important last episode, but for real, in add-ons, make sure that you have Node Wrangler. Because today we're actually going to be going over shortcuts that depend on it. Okay, so we're in the shading workspace. We have the default scene with the default cube, which has a default material. Again, remember, our cube has a bunch of faces. Each one has the assignment of this material, which we can name anything. I'm just going to call it default material. And you can see that when we change this color, it's actually changing this node network, which is the material which is on the surface of the object. We already went over this. I'm not going to keep talking about it. So today, I just want to talk about how this shader editor works in the first place, and then we're gonna kind of get rid of this big node and replace it with something that we can actually manage. But before we do that, let's talk about some basics. So you're in the shader editor, and you see me, zooming in and out, navigating. How do I do that? Well, pretty much all of Blender is pretty connected with its hotkeys. There's still a couple exceptions to that, which they need to get to. But most of the stuff makes sense. So for example, in the viewport, how do you navigate? Well, you hold middle mouse to pivot. You can zoom in and out by scrolling. You hold shift to do this thing, and it's pretty similar. So in the shader editor, which is 2D, not 3D, we zoom in and out with the mouse wheel. We pan around by holding, middle mouse button, and that's pretty much all there is. There's no 3D rotation for this 2D thing. So zooming in and out and just moving around. Okay, cool. As for the nodes, we can select them by clicking them, do box selection, Alt-A to deselect, same stuff as usual. I'm assuming you've probably used Blender a bit and you're not just hopping into this first time with materials. Yeah, so we move around, we select. For moving nodes, you have one selected, you hit G for grab, and it works exactly the same. Pretty much every shortcut you already know works here too. To delete something, you hit X, and you can undo it. And again, X over here, it's all the same stuff over and over and over again. And yeah, I think the only other shortcuts we're going to be talking about right now, there are a ton, but for right now, we want to talk about how to quickly disconnect and connect nodes. And normally the way you do this is you just hold this connection and drop it into the background to disconnect, and then you do the opposite to connect, and you can do that to any socket of the node. But since we have Node Wrangler, the fast way to do it is you hold Control and then right click and drag to cut. So again, Control, click and drag to cut. This works if you have multiple connections. So I'm going to draw a line passing through all three of them. And now that's gone. And then for fast connection, so instead of doing this, what we're going to do is hold Alt and then do the right arrow or right mouse button drag. And you can see that it's highlighting which nodes are going to be part of that connection. So if we duplicate this, by the way, duplicating is Shift D, or you can just, copy, paste, should be, yeah, there we go. Same commands as always, seriously. If we have two of them, we can hold Alt, right click and drag, and then choose which one we want to be fast connected. We're going to do this one, then let's do this one, and we hold Control and right click to sever this, sever that, and that's pretty much what you need to know. So pretty much right clicking is the thing that lets you do Node Wrangler stuff, and you either hold Control, Alt, and there's also something for Shift. So for Shift, if you hold Shift and then do it, you're going to see we get this line, and when we drop it, it's going to have a hinge. I'm sure there's a good name for it. I think it's called rerouting. So the point of this is, let's just delete it. Instead of having something like this, which can get pretty messy when you have a bigger node network, you hold Shift, right-click, drag, and you have this nice thing that you can reroute everything to. It still has the same information, but whatever. Okay, cool. You now know hotkeys. I hate talking about them, so we are done with them. And by the way, yes, G for grab, but rotation and scaling don't do anything because it doesn't really make sense in this context. Okay, so now some other basic stuff before we switch out this node for other types of nodes. You can think of this as this giant green principled BSDF is basically holding a lot of information about what we want our material to look like, and then we're sending all these instructions through the connection or the noodle to the material output. And more specifically, it's going to the surface socket, meaning take everything here and send it to the surface, the material surface of any object that has that material. Pretty simple. So it doesn't really matter where this is. This is the same node network as this one. It's really topologically equivalent, or there's a name for that. There's like this doesn't matter. Doesn't matter. I was gonna do some mathy nerd stuff. So what I'm saying is, if we have two of these, one's red and one is blue, no matter what we do to this, it's not gonna matter until we make this what is connected, and vice versa for this. Doesn't matter. And again, Control, right-click to sever, Alt, right-click to connect. And if you can't remember that because your brain, I don't know, can't handle that much information, you just do it like this. And yeah, there are many more hotkeys, but let's ignore those. So instead of messing with this principled BSDF, that can get pretty confusing. You have color, you have how metallic it is. I mean, you can just kind of drag these things and see what they do. Here's roughness, it's like how much does it look like a mirror. Instead of doing all that, what we're going to do is we're going to simplify. So instead of that giant thing, we are going to add a node called the value node, which is the kind of the atom. It's the base, most basic node you can have, and then you build up from there. So to add, you do the same thing as in the viewport. So viewport, you do Shift-A, or you just click Add and then choose what you want to add. Same thing here, Shift-A to add a node, or you just go to Add and select your node. So we're going to do Shift-A and then either go to Input and then pick Value, which is going to add that. You can do that, or you can do Shift-A and then type it in right here, Value. And I think you can just hit Control-A. No, that's a function nodes thing. Shift-A, type in Value. And this is how I like to add all my nodes, because once you know the names, you kind of don't want to go through the menus. So again, we take this, we connect it either that way or Alt right click, and now you can see that it went from black to, gray or white or something. And this node isn't as scary as what we had before, which was this giant thing called, again, you can just type it in, principled BSDF. I mean, compare these two nodes, if you know what I mean. Okay. So we have a value node which has a value. Right now that value is 0.5 and we can change it. And by the way, when you hover over something, it tells you what it does. So default value, input value used for unconnected socket. Sometimes it's going to be more useful than that description, but whatever. What we do is we take this and change it, and you can see our cube is going from black to white, etc. And if we look more closely, notice that as we go down towards 0, it gets darker. And then once we get to 0, let me just type it in, it's a pure black. And if we go to negative, so even lower than that, it stays black. Conversely, if we go up from 0 towards 1, it turns more and more white. And then because of a technicality, which we'll talk about in a second, you can even make this bigger, and you can kind of tell it's getting even brighter. So 1 compared to 10, 10's brighter. But normally, we use the value node for numbers between 0 and 1. Of course, this isn't always true. I mean, we have so much freedom. We can put whatever we want. We can even type in something like pi, and it's going to give us, an approximation 3.142. And if you click this, it will give us like 6 digits or something. You can put in whatever number you want, fractions, negatives, whatever, giant numbers. But there is a reason that we'll talk about that we go between 0 and 1, which makes me think, okay, well, if 0 is black and everything under 0 is still black, and 1 is white, why does it get brighter than it is currently when you go above 1, right? If I'm saying it goes from 0 to 1, why is this showing something different? And, there's a lot of reasons for what I'm about to explain, but really this is just a color management thing. So if we go to the Render tab and we go to Color Management, so Render tab, Color Management, in View Transform, it should by default be set to filmic for you, I think. We're going to take this and switch it to standard. And basically what this view transform is, it kind of tells Blender how to handle colors. So standard kind of works the way you expect it to. So 1 is white, and if we make it brighter, nothing happens. Nothing's happening, meaning 1 is the cutoff and 0 is the cutoff for black, meaning that you can still do something below 0 and something above 1, but it doesn't really matter in this sense of seeing the color on the surface of our object. Something like Filmic has more high dynamic range or whatever, and that lets you go even higher than 1. So maybe you can think of it as a I don't want to say 1 over x, but I'm saying that you can keep getting brighter and brighter and brighter, and as your numbers get huge, how much brighter it gets kind of slows down, but you can always keep going. So it goes from like 0 to infinity instead of 0 to 1. I'm just saying keep it on standard and don't worry about it. So there you go. So we have this on standard. We go to 0, it's black. Negative is, still black, anything under 0. And then we go all the way up to 1, and then nothing happens. Okay, cool. So now we know the value node, and this is a great way to make an object either black or white, and you're thinking, okay, I don't know what this has to do with anything, but it's a good fundamental thing to understand because we build everything up from this. So hopefully you understand the value node. We can have two value nodes, one's 0, one's 0.5. That's a comma, 0.5. If we take this and connect it, what's going to happen? Think about it. It turns gray, so somewhere between black and white, halfway in between. If we change this one to 1 and we connect it, what's going to happen? Think about it. It's going to become as white as possible, assuming we're in the standard view transform. Okay, cool. What about negative numbers? We said that it's black, so how do we even know that it's actually storing this number? What if it's actually just, if it's a negative, it just says that it's 0 and makes it black, right? Is there a difference between -1 and 0? So here's -1, here's 0. Is there actually a difference? And I would say there is, and I'm going to prove it to you. So we're going to have two -1s, and now I'm going to teach you about another node. So you can go Shift-A to add, and then I'm trying to think where it is. Is it in Converter? I'm looking for the math node. So in Converter, you're going to find math, or of course, Shift-A, type in math node. Okay, cool. So now we have something a bit more complex. It looks a bit bigger than the value node, not as big as the principled BSDF. Okay, so if you go to this math node and check the dropdown, you can see there's a whole bunch of mathy stuff, which some of it you may recognize, some of it you don't, but I can guarantee you recognize division, multiplication, subtraction, addition, and that's what we use for most of our mathematical operations. So, I mean, if you're scared by this, get out of here, okay? It's just addition, subtraction, multiplication, division. You can handle it, I swear. So what we're going to do is I'm going to set this to multiply. And you can see it has two values. We can connect this. Let's connect this to our surface. And notice that right now we have 0.5 times 0.5, which is 0.25, which is, it's closer to black than it is to white because it's, closer to 0 than it is to 1. If we do 0.5 times 2, which is 1, you can see this turns white. So if I make this value node 1, so these two things are essentially equivalent. Here we have 1, here we have 2 times a half, which is 1. If we switch these, nothing really happens. It looks exactly the same. Okay, cool. So you can either just, put in numbers here and here and have it do an operation, or you can instead plug in numbers instead of just typing them in here, which is good because you can control them from separate nodes. So let's take this and connect it. So we have -1 multiplied by -1, and it gives something that's white, because -1 times -1 is 1, which is as white as you can get. But that proves that -1 isn't like rounded to 0, right? Even though it's black, it still has that information. And hopefully you understand what I mean by this. If these were zeros, this wouldn't work again. So times 0 is going to give us 0, because anything times 0 is 0, and I think you get the point. We can also do other operations like, let's say, addition. So -1 plus a -1 is a -2, which is under 0, so it's black. And if we want this to be exactly white, we would need this to be 2, because 2 plus -1 is 1. If we want this to be exactly 0, we put in 1. 1 plus -1 is 0. And then if we make this anything bigger than 1, it's going to be slightly more closer to white than it is black, right? It's going to become gray, is what I'm saying. And you can see that in action. Okay, there we go. That's pretty simple. I think you understand. Of course, the math node, let me undo that. The math node has tons of operations like, sines, cosines, trigonometry, and then also some other things like greater than or less than. Let's just do one of these. So greater than, we'll check if, it describes it. 1 if A is bigger than B, else 0. Meaning, if something is bigger than another number, it's going to output true, meaning white, otherwise it's going to say false, which is 0. So let's try it. Let's see 2 and 1. Is 2 bigger than 1? Yes. Let's try it. 2 greater than 1 outputs white. So it's outputting 1. If instead I made the 0, is 0 bigger than 1? No, outputs black. Now if we make these the same, I'm not sure what it's going to do exactly. I guess it's going to output false because greater than is like strictly greater than. It's not greater than or equal to. If we make this anything bigger than 1, immediately it shifts to white. And I think you can probably understand why. So math node, tons of stuff. And then the last thing I want to leave you with for this introduction is we have value, which is one kind of grayscale. If you think about it, it's either black, gray, white. You can't really get any color out of it. How do we take this and then level up to color? Well, the way I want you to think about this is any color, it can be described by how red, green, and blue it is. So red, just the color red is 100% red and 0% green, 0% blue. And then, and then something like purple is like, half red, half blue. It's like mixing colors. We'll talk about it. So what we're going to do is we're going to do Shift A, and then is it converter? We want a combine node. Let's see, is it in here? Yes. So in converter, you can see all these combines. I'm going to add a combine RGB, or you can just type it combine RGB and just add that in. And we take this, and you see it has a yellow socket, which normally indicates, color or something that isn't grayscale. So you can see values have this kind of grayness to them, and these 3 sockets for inputs are also gray, and it outputs something with color. And we'll talk about what green and purple mean and all that, but let's just connect this, which gives us black. We can take this and make it more red, so you can kind of see what's going on there. We can make it more green, make it more blue, or we can mix them. So if we take something that's 1 on red, meaning 100% red, and also make it 100% blue, we got purple, right? It's mixing colors. If we do red and green, I think that's yellow. Yeah, and green, 100% green, 100% blue. What does that give? I guess it gives like teal, turquoise, something like that. So normal mixing colors. And again, we don't need to type it in these sockets. Instead, what we can do is we can have 3 value nodes. Again, that's Shift D to duplicate. And I'm just going to connect them. And again, use the Alt right click thing for the shortcut. And you can see that we have something that's perfectly white because it's 100% red, 100% green, 100% blue, meaning that it has all the colors and that's white. And of course, if we change these to 0, we get black. Okay, cool. And you can see that if you pull this slider, it doesn't let you go under 0. Maybe you can type it in. Nope, it just rounds to 0. It doesn't let you go under 0 or above 1. And this is what I'm talking about, where a lot of nodes just want you to use the 0 to 1 interval. Of course, you can type in over here -2, and we talked about how it actually stores that. But yeah, I mean, 0 to 1 is what we're using a lot of the time, so we need to get used to it. So we have combine RGB. Let me just reconnect these. And you can see the nice thing about Node Wrangler is it will automatically detect if a socket is filled up. So if we do this, it's going to automatically go to green, and then to blue, and then whatever. So let's just set all of these to 1, making it perfectly white. And I just want to play with this a bit more so you understand. So here's blue. We can take this down, and if we remove the blue, all we're left with is yellow. Doesn't matter what arrangement we have these in. Again, it's topologically equivalent. It's invariant to change. There's a word for this again. Doesn't matter, but it exists. Yeah, so you can just slide these around. And then you can also do the opposite operation, where if you have a color, so instead of combine RGB, we can just add an RGB node, which is kind of like skipping the middleman of choosing a red, green, and blue. I mean, you can, pick your color wheel and then set RGB values, or just, choose it from this color wheel. Conversely, let's put this, so it's going to be, this shade of green. We can do the opposite. So instead of taking 3 numbers, combining them into what is a 3D vector, don't worry about it right now, and then, showing that as a color, we can take this 3D vector, meaning just a list of 3 numbers, how red, green, and blue it is. We can take that, and instead of a combine RGB, converter, separate. Where is it? Separate RGB, or just type it in. And in the beginning, you're probably not going to memorize these names, but that's fine. And what the separate RGB node does is it takes our RGB, our color that has some amount of red, green, and blue, and then separates it instead of combining it. So I'm just going to choose a color that is, pretty much perfectly green. So you see red, it's outputting black, which means it's 0. Again, black is 0 or negative, but in this case it's 0, meaning this shade of green has no red in it. If we do green, you should expect this to be somewhat white. Perfect. And then blue, it should be close-ish to 0. Let's see. Yeah. And then if we bring this somewhere over here, that's kind of like a turquoise, we can expect our blue to become, think about it, slightly brighter. Cool. And we can actually put in exact values. So let's have this be 1, 1, and 1, meaning that blue is going to be 1, green is going to be 1, red's going to be 1. We can make this exactly 0.5, and it's only outputting our red, which is 0.5. So if we add a value node of 0.5, this should look exactly the same. There you go. And of course, you can mess with stuff in between. You don't have to immediately connect it to the surface of our material output. We can add in a math node. We can add in a math node, as we talked about. So here we have red value of 0.5 and 0.5, and we can just add these, making them 1, perfectly white. And then we can bring that down. So if I make this 0, it's 0.5. If I do negative 0.5, so again, 0.5 plus negative 0.5 is 0. So yeah, there you go. I mean, we can always dive into this a bit more. So, there's math for combining values, which is one number, but there's also math for combining colors, which are lists of 3 numbers, and there's ways to do that. But I think this is a good introduction to the hotkeys, to simple nodes, and to me ending this video very soon. If you enjoyed this, you can subscribe. These are all things you can do. But if you want to support me in a way that sees results and lets me keep making tutorials, please donate to my Patreon. There's a link in the description, and you also get benefits, but that's not the point. You do it if you want to support me, but it is your choice. That's all I have for you guys.